much for inviting me here today. It's an honour. Not only is it an honour, it's a pleasure to return. I've actually talked to this group before. In fact, even coming out of the MARTA station, Roman was kind enough to recognise me. And you might look at me and say, well, if it's an honour for this guy to speak, why can't he put a time on it? Be quite reasonable. And we'll have a solution to that at the end of the presentation. So, Sam, if you could put that first one up, that would be great. I've heard the definition of a professor as a man who has the really bad habit of speaking in somebody else's sleep. And I really don't want to do that. I don't want to put you to sleep today. So I'm going to talk a little bit about cognitive workload, but I'm going to ask you to ask questions. You need to ask me specific questions that you have in mind. If you don't, that doesn't work, but don't worry, I'm a tenured professor. If it doesn't work, I'll come up and ask you myself. I'm that sort of mean. Now, I've actually come from Orlando, Florida, so that means I'm in Atlanta, Georgia. That means I'm at least one state away from my wife and daughter. So today is what I call a win-win. We're going to have some fun. Okay, hit that first one there, please. Let me start off with, yeah, don't worry about that, that's just a placeholder. If you go to the next one, then. Oh,
Dr. Hancock, I'm sorry if I can interrupt just 1 second.
You can interrupt all you like, James. I should find out.
James. We are filming this presentation. Obviously we don't record operating committee meetings, but we did ask permission to record from Dr. Hancock. So if anyone has a concern, realize that we are videotaping just this particular presentation.
It's not a problem for me. Okay, so one of the things that I want to lay down on the table here as I talk to you is a question of why human beings should be such a problem. And so I'm going to tell you a little story. I do things through stories. That's my most interesting thing to do nowadays. And I want to cast your mind back to some of you will know about the Enigma machine that was so pivotal in England, winning the Second World War against Germany. It was the code-breaking machine. And it's an analogy to the human brain and the problems that we've got. Why is it so difficult to understand this system when you already have a complex system that you have to control? And if you cast your mind back to Enigma, there were 3 rotors on the original one, in the one that was captured in Poland, and there was a plug board. And what would happen is you would put an input in there, you were used to inputs, and it would then give an output on the board, and then it would rotate the rotor so that there was never a double output of the same sort. There were a couple of little wrinkles that the Germans shouldn't put in. They didn't like it to actually give the same one twice, even though it could have done. And so it's extremely hard. It was a black box problem. You've got inputs, you've got outputs, you've got pretty much guesses of what the input is, because that's the message, and you've got some gibberish for output that you've now got to decode. But in principle, it's a soluble problem. And it's a soluble problem because there are certain properties of there. And in fact, that's where computers come from. The computational nature of the problem was that generated the tool that is sat in front of almost every one of you right now. So now what makes human beings a little bit more difficult? When I look at you, when I look in your brain, and I do that all the time, that's all that I do. I wander around looking into brains, and they're very fascinating things to do. And if I take an average neuron in that brain, of course there's no such thing as an average neuron, but if I take one, it's got 10,000 connections going in, and about 10,000 connections coming out, on average. And the interesting thing is, one of those connections going in comes from the outside, and one of those connections going out goes to the outside. The rest talk to each other. And sometimes, unlike the Enigma machine, when you press the button, nothing happens. It's called lecturing. I do it to students all the time, right? And sometimes things come out of the machine you had no idea were there. Because 10,000 neurons are talking to each other inside this system at all times, and it isn't pure input and output that you're trying to decode. That makes it not a wicked problem, that makes it a damn difficult problem. And so when we talk today about cognitive overload, we're going to talk about generalities, we're going to talk about the limits of what is currently known, and I'm going to tell you when I stop and when I don't know anymore. So I'm going to talk generalities, you're going to ask specific questions. There's James's graduate career. I knew he was at the university somewhere, I wasn't quite sure exactly where. Yeah, look at it carefully, this is... but I'll tell you one thing about Merlot that you have to know. He's a wonderful cook, okay? That's the way you see him graduating in the top corner there. Why? Because his fried turkey is second to none, and I strongly recommend that you all put yourself together next time, sometime around Thanksgiving. So I want to thank James for coming today. I really appreciate it. So here's what I'm going to do. Number 1, I'm going to talk about 2 brief projects. You can't get onto the rock face of what we're trying to get over here without some pitons. I understand that. I'm not going to ask you to ask questions that are cold. I'm going to ask you to ask questions maybe in relation to some things that I'm doing. And there's two of those. The first one is work we're doing for NASA. It's a very, very similar question that you have, which is the problem, something called envisaged world problems, and I'll talk about those. The second one is for the Nuclear Regulatory Commission. I'm not going to go into details, but it's all about the same thing, prospective workload. Trying to say how much cognitive demand is too much in a system that doesn't yet exist. And that's certainly true for Mars, and it's certainly true for some of the new versions of nuclear power generation. Then I'm going to talk about the current methods we use. I'm going to look at some tools and techniques, and questions are welcome at any time. I might postpone questions, so in other words, you might ask me and say, well, what about this right now, Hancock? Sort of give you some more here. So I've heard you mention situation awareness many times. I can talk ad nauseam about such things, but I might postpone you as a question, but I won't ignore you. So please feel free to jump in. We've got 45 minutes, and I'm certainly happy to stay afterwards during any break that you have. So one of the great ideas in terms of trying to reduce cognitive overload, the standard response has always been, well, why don't we just automate that? Okay, this is what's called the progressive degree to which the human, the operator, is now taken out of the center of the control loop. And I put up the transportation version there because that's the way that most people in our society are going to see the penetration. It's coming down the pipe now. You can see a picture of me in the Google car. If you look in the back, I'm not allowed in the front. But there's the Google car flying along on 101 just south of San Francisco. And here it is doing straight line driving. We are already seeing models that can do this sort of computation. Certainly longitudinal control, certainly lateral control, and you'll also get things in backing up. What you'll see is the slow penetration, in this case, of automated systems, semi-automated systems, some of which take the individual out of the control loop completely, some of which make them peripheral to the control loop. And you'll find that slowly, piece by piece, that's the interesting question. Where do you put people in control loops, which in this case can get unstable at the lowest level of operation? So let me go forward with that. All right, Sandy, you're going to have to be a robot here. I think you're going to press the next one if you would. Okay, so there are some people who work in this area almost exclusively. There's some very good people I think you would do well to talk to. Sadly, we can't talk to one of them. That's the person I just referenced there. My colleague, Raja Parasuran, recently died. This is Tom Sheridan. He's a professor at MIT, or was. He worked at Lincoln Labs. And the thing they pointed out in their work, which is absolutely critical for you to understand, is the idea that automation doesn't replace human performance, it changes human performance. And so the great problem quite often with automation, as you engender it into your system, is that what happens is you take people who are really quite competent at what they've been doing, you now inject a new work element into there, and what happens is you now create for them a new occupation for which they're not very good at. And some of the other things that we don't get to deal with in here, some of your operators are proud of their skills and what they do. Some of your people are interested in what they do and take pride in their work. And as you now take them away from that part of the inner control loop, you also take away that dimension of work. And that's an important dimension of work. When we talk about robotics, maybe I'll talk about robotics a little bit, you start asking the question, what don't you want to automate? Go on, hit it again, Sandy, if you would. Okay. So if you want to take away a small little cliched nugget from myself here, and you can do that, if you build systems when operators are rarely required to respond, they will rarely respond when required. Why? Because human beings don't like being bored, okay? They will do almost anything to being bored. Now, you are really nice folks, and I can see you're all professionals, and most of you have got your laptop on the top here. Students have it underneath right now, okay? They can text and Twitter and not even look at the screen anymore. Some of them can do it behind their back, okay? And I look at them and say, come on, carry on, do it. Okay? Human beings don't like being bored. And I will tell you categorically, because I understand under load better than almost anybody else I know, because I get bored quite regularly, after 20 minutes you'll be bored with me. You'll be bored. Why? Because you have to be. because you are type A individuals, and I will look around here, and because I'm a psychologist, you've been given an experimental psychologist, I can watch all the various symptoms, and I'm looking for them now. I've got this one, down here, a couple more things you know to answer, okay? Because people multitask all the time, and even if they're not multitasking in the way we think about it formally at work, they're doing it anyway. And why? Because of those 10,000 neurons I was talking to you about earlier, about 9,000 are working without your conscious apperception at all. A lot of things are going on. You're doing a lot of evaluation, basically, of me right now. Why? Because I dance up and down in the middle. I make myself the centre of attention. I know how to do it. But out of the 100% of your capacity that you're devoting to me, 90% isn't what you are actually thinking right now. You're doing a lot of implicit evaluation. And so this is a funny thing that you're talking about, human brains. It just so happens that you've got one, okay? But don't think you understand it. I don't, well, I don't. Next one, please, young lady. Keep hitting it. No. All right. And one more. Keep going. I'm going to keep trying. And one more. Do you remember these? No, there's not enough grey hairs there. I'm an old guy. I got a nod. Thank you, sir. You're much appreciated. People used to do elevator operators. Most of you people in this room have never seen an elevator operator. Now, look at this guy. I put him up here. He's a happy guy. He's enjoying himself. Life has its ups and downs, as my daughter would say, for him. All right? Did anybody ever ask this guy, was it a good idea to automate? It was a social job. He probably took pride in it. You can see he takes pride in his appearance. Are we automating the hell out of life so we take the piss and enjoyment out of it? Be very careful what your industry is going to do, because some industries are going down that direction already. Okay? And I am writing against, I'm a Luddite. The guy on the right, he's actually at the Ritz, actually in London, took a picture of myself here. And doorman, here he is. Anyway, it's supposed to come there. And there's something called teletic work. I'm not going to focus on it today, I'm not going to talk about it, but it certainly relates to cognitive workload. Teletic means things that you enjoy doing, okay? Things that you enjoy doing. And one of the dimensions of cognitive workload is you'll be asking me, hey, what about these complex screens and displays that we've got? What about these multiple systems that we are putting in there? We're making this guy work harder and harder. But believe it or not, when you work hard at something you really like, cognitive workload is affected. And so not only are we increasing the demand placed on the individual, we are changing the nature of that demand so that it becomes quite boring and not rewarding. You're not giving the guy a puzzle to solve, you're not giving him the quality of work that will enable him to actually work with this workload level that you're now imposing. So there's a double whammy coming down the bus. I'm going to try that one. So let me just talk about NASA, because NASA is a very interesting case. This is a workload project we're doing with NASA. We just sort of started. Their question is pretty much yours, which is, okay, we've got these guys going. It's going to be about something like a 2-year mission. There's a 4-year mission. There's a variety of missions. Just wanted to show you why there's a variety of missions. Here is the inter-Earth Mars distance. You can see it oscillates up and down. And so the cost of going to Mars varies, in fact, by almost a doubling order of magnitude. And so there are windows of launch windows of various configurations of the process that actually work out. And so you'll hear projections and say, well, we want to go to Mars by 2030. What they really mean is we'll go to Mars by 2030, but we'll have 5 years worth of slippage, and that's the actual launch window we'll aim for, and that's the least propulsion it's going to cost. Will we get there? Possibly. One of the great issues that NASA has is the same issue you have. Suddenly something bad goes wrong. Okay? So here are what we have as simulations right now. We've run a bunch of simulations on the Mars mission. They come out of interesting brains. Okay? And what you find is you can rent all of these on Netflix. That's the homework, I guess, for today, is to sit and go and watch through all of these things here. What you find is all the boredom is taken out. Why? Because we don't watch boring movies. Right? So everything is off-nominal. Everything is looking at that high workload condition. If you take one thing away from my talk today, and only one thing, the hidden enemy that you have will be boredom. When you take people out of that inner control loop, when you stop asking them for a constant response of some fashion, boredom with the task is the problem. And the answer with boredom with the task is exactly what you're doing now. People find other things to do. They compensate. Human beings have recently been described as the information foraging animal. They look around the universe to balance that information, and if you don't give it to them in the task, if you don't give it to them in the job, they'll find another way of doing it. And even if you say, no cell phones in the operating center, no tablets, we're not having those, can't have computers going onto Google, what they'll do is they'll use that 9,000 other neurons that we talked about, and they'll feed on themselves. They'll daydream. Okay? This is a very interesting system. When you put it in there when there's no external capacity to process information, when you put them in sensory deprivation, they start to invent their own worlds. Very clever system. I've studied it for a while. Okay, so boring. Specifically, this is the roadmap that we have been asked to look at, or I've been asked to create and do. And what we're doing is a bottom-up and a top-down combination. So the bottom-up has a variety, in this case, of NASA-generated and supported research models that largely relate to circadian phase, and I can talk happily about those if you wish me to. And those are called KKs, known knowns. They want us to take that as a premise. I'm going to argue against some of them, because of course that's my job. But the point is that that's our foundation. Then we're working into these hybrid models where you try to take some certain foundation physiological models, things like rhythms of attention. I've already told you about one rhythm of attention. Let me talk about rhythms of attention, very interesting. Let me talk about Dan Fouts. Some people will resonate, others won't. Dan Fouts was a quarterback for the San Diego Chargers. And this guy loved to air the ball out. Okay, he picked up the ball, he would throw it every time he picked it up. I think San Diego didn't have a running back for 15 years, okay? And what happens as soon as you throw the ball? Well, you can catch it, that's a good thing, or you can drop it and the clock stops. So Fouts started playing, he started watching San Diego Chargers, and critically, absolutely critically, the game started to go to 4 to 4.5 hours, because the ball got dropped, and the clock stopped. And you know the clock doesn't run vertically, but it certainly keeps running. And after about 3 hours, people started tuning out. And suddenly the network's going, hey, we're losing market share, what's going on here? There is a basic rest activity cycle in human beings. They're called ultradian rhythms. They are inside 24 hours, and they're about an hour and a half to something like 2.5 hours. So when you look at things that entertain people, that's how long they last. Why? Is it because the script says that? No, Eisenstein's The Sorrow and the Pity goes on for 6 hours, all right? Occasionally you can find something that goes for 3 hours, but my daughter and wife walk out pretty much. But the point is, you go to a movie, it's an hour and a half, it follows that thing. You go to a soccer game, it's an hour and a half, it follows the notion. And you also have a little mini break in between. These are not happenstance, this is what human beings will pay for. They'll pay for something to be interested. Did you know that your operators will actually pay to work if you can show them something sensible? Ooh, well, there's a strange thing. All right, let's go from the top down. Here's where you can work, and here's a known unknown, which is we have the envisaged world problem. Now, this is always context specific. I don't know your business, but I'm getting to. I think it's going to take me about 18 months to be really dangerous, so that I absolutely don't know what the hell I'm talking about, but I certainly will be able to say RAS, what was the other one, a PMU, Schweitzer. I was picking up so much stuff last night as I was oiling my alcohol intake. It was great stuff. I even learned about Jim and the Nimitz. I'm going to steal 2 of those stories, because they were absolutely fun. Thank you, gentlemen. The envisaged world problem is your problem. I don't know your business, and I'm not going to know your business. In a human factors professional's life, you could probably learn 2 or 3 areas at most. I spent a lot of time learning Air Force, I spent a lot of time learning Army. I'm not going to learn power generation. I've got somebody who helps me with all those notions. I can't tell you what they are, but you've already mentioned in relation to the alarm effectiveness work that was presented earlier, subject matter expertise, absolutely critical. You now need to move today, not tomorrow, today, to capture the expertise you're losing, because if you don't formally capture it, you'll be going around like we are now, trying to find a way back to the moon from guys who have not just retired but are now underground. So it's absolutely critical that you capture the expertise about the system, because there are legacy elements of the system that are critical. Our subject matter experts here are all astronauts. There's not too many of them. They're sort of finding like jewels on the beach. But we have about 10 or 15 astronauts. Most of them have been on orbit for something like 40 to 50 days minimum. They're very rare. There's Russians, there's Americans, and there's one or two others. And then we're trying to look at physical and cognitive task analysis. Again, I'm talking about, I'll talk about those if you ask me to, and we're trying to merge those together. So you have known unknowns, this is what I know, I don't know, and then you have known knowns, this is what I think I know, and then in the middle you have something that Sheridan called unknown. Those are what are called dangerous or wicked problems. I don't know, but I also don't know that I don't know. Those are the things that bunch of back say. Okay, quickly then, the NRC work that we're doing, the same issue, same problem, an envisaged world. In this case, next generation of nuclear power generation is certainly going to take advantage of the maybe even decades of development in technology that have occurred in the interim. There's going to be people wanting to build these. They are profitable organizations, they're profitable systems, but then someone's got to regulate them, and I guess you guys know more about that than I will ever really want to know. But the question is, you have envisaged world problems, which is, here you have a couple of operators, they're trying to deal with an off-normal event, and we are measuring them. I'll show you how we measure them for cognitive workload. But the most interesting thing for me is that the first thing that these people did in this particular project, it's not my project, I just consult on it, but the first thing they did was to take a very old technology and reproduced it on the screen as a visual image. So pretty strange way about going about things, but quite a common way. And we'll talk about interface design, which has a critical effect on how people react a little bit later. So, what is mental workload? I'm going to talk about that. Why measure it? Why bother? What methods are there? And what are some of the future directions we've got? James, you need to keep me on time here. I need to see numbers. Okay, so here we go on the left-hand side. This is an absolute classic icon. It's not a guy actually doing work, it's a model pose, but it's about the middle of the century. Here you go, we've got work, and we know how to measure this, okay? We know a pretty good idea how to measure this. That's the number of nuts tightened to a specific criteria per unit time. And that's work, okay? And as I look at you and I chop your arm off and I have a look at that physical muscle, I can pretty much tell how hard you're working. How hard are you working right now? How hard are you working? Pretty hard. I said, keep up, good luck. I like you already. You're coming back with me. That's good. Okay. Other people are not working. How hard are you working? How can I tell? How many nuts have you tightened in the last 15 or 20 minutes? Well, it's not just a problem of creating work systems. It's also a hell of a problem in how to reward things, right? Look at James, for example. He gets lots of rewards. I have no idea if he's working hard at all. Or is he hardly working? How do I do that? Have I got a dipstick I can put in his head? Well, maybe I can. Maybe I can look at that. But when I move from the left to the right, when I move in this case from physical work to sort of information-based work, how hard is somebody working? What happens if I have a Nobel Prize winner? How many Nobel Prize winning ideas have you come up with this week? All right, I'll have 3 of those, and then I'll say you're working 60% capacity. I want 1 per day. Yeah, it starts to become difficult, not just for us prescribing work in relation to a system we're building. It becomes a problem in society. How do you reward people? Are you working hard enough right now, Joe? I think you are. I'm going to say you are. And so we have this sort of notion. This is, on the left-hand side, this is taken originally from one of the publications around sinking the Titanic. And this is a typical guy here that we've got working in a FAA simulation terminal control area experiment. And so what you have now is, on the left-hand side, is a guy who seems to be almost half asleep, catatonic, doing nothing. It looks like it's underload. And the guy on the right here, he looks like he's pretty solid professional. Looks like he's working away pretty hard. So it looks like the guy on the right is working hard and the guy on the left is not working hard. But remember I talked about that control loop. Now here's the problem. Here's the first problem. When you take someone away from the proximal control loop, when you bring them one step back, and they become a manager of a system and not an operator of a system, then you have the rare event signal things I talked about when somebody rarely responds. Now, it might appear that this guy on the left is actually not working hard. But in reality, enforced vigilance, that is, you having to pay attention to that rare alarm that comes up over a period of time when there are serious and problematic consequences to missing that alarm, turns out to be very high cognitive workload. Who knew? One of the discoveries of the last 20 years maybe. Vigilance, enforced vigilance, okay, turns out to be high workload. And if you do it all the time, it is really quite excoriating stuff. It will sort of be soul-destroying as well. But it looks like it's not doing much. Because when you look at the person who is actually doing the vigilance, they're not doing anything. And then you get a nice administrator coming, sorry, any administrators in the room, because you're going to take it in the shorts here. I hate those people with that. Okay, they come in the room, but he's not doing anything. He's not doing anything. I mean, why are we paying this guy? He's not doing anything. And the better the system you build, the more they come in and go, yeah, but he's not doing anything. But you've now created a very high workload situation, even though he's not doing a lot of physical things. It's a paradox. And human beings hate that. They hate that. All right? If you ever want to come down and be absolutely bored, we've managed to turn video games from EA Sports into boring events. We have students who actually now physically find ways of going around and not coming into our experiments because they're so boring. And so we have some students who work at Full Sail who've got to take sort of semi-boring things like Mario jumping all over ladders and whatever and try and make them exciting. And so we're doing the opposite as well. But be careful that when you start to design systems, it's all very well talking about that multiple alarm problem when 47,000 things go off all at the same time. That's the high event. That's the high publicity event. That's the thing people get notice of. They don't get notice of the underling. It's a hidden killer, and it's going to kill the people on the way to Mars. All right, so how would I start to measure this if I'm in your place? I would do 4 things. I'm only going to do 3 today. I'm not going to talk about secondary task techniques unless specifically asked to. So the first thing you can do, primary task performance. What is the person actually doing? How can I track it? Now, obviously, if the person is doing something continuous, like driving a car, I can track that particular driving capacity. I can use all sorts of analog measures. Typically, we use things like standard deviation of lane position. You look at it as an analog signal, and you can take almost any derivative out of the analog signal, and it gives you an overall idea. And if, in this case, they minimize the level of error, you can say, well, he's doing better. Primary task performance, there's 6 buttons to press, you press all 6, well done. Okay, so there's some good face validity to that, but there's some shortfalls. Subjective report, ask them, ask people, talk to them. Most people will tell you how they're doing. How are you doing, Sam? You all right? It's interesting. I keep paying you a bill, Sam. I'm not quite sure why I do that. Don't cut me off in Florida if I say something you don't like. Okay, so the point is that I asked Sam, and he's not a bad transducer of what he's actually feeling, okay? And most people, most of the time, will tell you what they're feeling and pretty veridically. So ask them. If they're bored, they'll say, I'm bored, don't do this, don't kill me. And the last one, which gets a lot more issues, are physiological measures. And of course, we'll talk about those in detail, what I use as a suite and what we do use as a suite. So let's have a look at some of the advantages and disadvantages of taking these particular ones. So first of all, primary task performance. The data are available. You see that production data coming out. You can track it. You should track it. It should be one of your primary, oh, sorry, am I not interested? Okay, come back. Sorry, don't worry. You can ask questions. It's one of your primary outputs that you actually want to track on a day-by-day basis. But the problem is it doesn't tell you too much about prospective failures. All right? It'll tell you maybe how the system's oscillating up and down. It'll give you some ideas, but it really doesn't give you that prediction that you desperately want. It'll give you some tendencies, but you really want to examine that point failure, which is coming up in the data stream. Secondary tasks, the ones we're talking about, I'm not going to talk about today, but subjective tasks. High face validity. When you ask people, they appreciate you asking in the first place. Okay? And there are standard procedures used for obviously face validity, but they dissociate. We'll talk about that later. And physiological assessment, and we're going to see that more and more and more. They can be unobtrusive. They can sort of be expensive data, but a lot of them are getting much cheaper. And you are already subject to physiological analysis. Believe me, I will go through Atlanta Airport. There will be a variety of those things. And if I really want to play with their heads today, and I don't today because I want to get home, but if I do, I'll adopt all the 27 characteristic ones they don't like, and I'll shade my eyes, and I'll do all sorts of things just to trigger them off, just to play with them, because that's what administrators are going to be done. All right, so primary task performance. Yeah, if you know the profile. So here's the question, how How well are you working? How well are you flying? How well are you driving? So when I talk about primary task performance, it's not easy because the word well is the weasel word here, okay? So when you talk about flying, you're not doing just one thing. You're not just controlling the aircraft. You are aviating, you are navigating, you are communicating, you're doing multiple tasks. And when you're doing multiple tasks, especially in aviation, the question is, how do I combine those together? Okay? I might be absolutely wonderful at momentary control of the stick, or I might have pressed the autopilot. But now I've got something else I'm going to do, which is communicate. And I might be doing lousy at that. But again, navigating, I might be very good. I might be exactly on point. I might be exactly at the altitude I want to be. So now how do I put those together? Because when you're talking about your operators, again, they're not doing one thing at a time. They're doing multiple things. So when I said primary task performance, it's so easy to just see that output stream as though it's undifferentiated. Okay? But it's not. And so this is what makes the problem difficult, because you have to put them together. NASA tried in the 1990s and early 2000s a region area called Figures of Merit. Figures of Merit was an idea to generate thresholds, and I'll talk about thresholds in a second. And what they did, if you want to know technically, if there's any statisticians among you, is that they looked at individual performance on all the subtasks and tried to do combined Z-transforms on those individual subtasks in order to attain an overall figure of merit and match it, in this case with subjective workload. It didn't work for certain interesting technical reasons. I'll go into them if you ask me, and because you can ask me. The other thing on the other side, of course, is driving, which we do much more frequently individually, and that's the great question that now we're asking for Google and Mercedes-Benz, as the car manufacturers suddenly realize that they've created a computer on wheels, and the computer company realizes they've now got a computer with 4 pneumatic tires on, and that'll be an interesting challenge in and of itself. So, primary task measures. Ooh, that's not good. I should have made that right. Okay. Non-invasive and non-interfering. Very good. You don't want to do that to people. They've already got their work to do. Tracks changes in workload, but of course it is just purely reactive. But it's uncontaminated by memory issues. One thing we'll find is subjective workload is contaminated by memory. Let me talk to you about Danny Kahneman for a second. Wonderful stuff. Kahneman, who I recommended to that young lady over there, Tryon, I recommended she looked at Kahneman's book, Thinking Fast and Slow. I'm not shilling for Kahneman, but it's an interesting book. Kahneman won the Nobel Prize. He won the Nobel Prize in economics. That's the only thing open to psychologists, by the way. It's only been won twice by guys who would call themselves psychologists, and they actually won in the category of economics, and Kahneman was one of them. And what the hell do you do after you won a Nobel Prize? I presume you sit back and spend $1 million. I'm trying to win one for the money, as my wife would put it, and not for the prestige at all, and I don't have that good ideas. So I'm trying to get NERC to support that. So we're in Sweden. I'm sure we're working on it right as we speak. But the point is, what do? What does Kahneman now do? I mean, you've reached the top, right? It's sort of like, hey, Rob, where are you going to go? And Kahneman went back to basic work. He went to proctology, and all things go strange. What's going on? Yeah, interesting thing. And what does Kahneman do? Very, very interesting stuff. He started to look at those wonderful examinations that you and I have when the doctor puts you into, now it's twilight sleep. It didn't used to be when I started. It used to be have the whole experience, right? And Kahneman looked at those. He thought, Nobel Prize winner, Kahneman? What's going on? Yes, he did. Okay. And what he found was very interesting is that people classify the pain of the experience by the peak of the pain of the experience. And if we're going to be anatomical, and I presume we're all professionals, that's the going in and the coming out. And so what you find interestingly is human beings are not very good in memory. They don't average across the signal, as you sort of think they would. They actually code the peak experiences. And what Kahneman showed to our proctology friends is, hey, if you minimize the peak experience, people will sort of go, oh, well, it wasn't good, I don't want to do it on a regular basis, but it wasn't too bad. But if you are invasive and insensitive, they're going to really code that. So the problem is with subjective workload that we're talking about here is people code the highs. They code the highs and they code the lows. They're not very good transducers. And it's the same for you. If I look back at you and ask you, what is your memory like? And I start to quiz your memory, as you will have to do about subject matter experts, and this is why it's so time-consuming and painful to do, is because they will give you their best war story, all right? Because that's how human beings code. That's how you will remember. Everybody got into the vigilance decrement here? 20 minutes? Yeah, I can see all of them here. I sit and look at people there. Yeah, we look down there, I'm relaxing. The standard management consultant thing is to ask everybody to stand up and start stretching now. I don't ask you to do that, I ask you to lean back and go to sleep so that I can actually inject some more information in the implicit side of things. All right, so disadvantage. It's only positive.
Got a question over here.
Oh, shoot. Who's got questions? Yes, sir.
I'm Bob Metrican from Everett. I didn't get quite the point. You say that people remember the highs and lows, but I'm not quite sure if that's a good thing or you're looking for them to keep things steady.
Okay, so if I'm looking at measures of cognitive workload, and I'm looking at primary task performance, I'm getting a continuous signal. Okay? But if I ask them questions, I've got to ask them questions after the event. Okay? So the subjective measure, which people often want to take because it's simple, cheap, and it can be done fairly expeditiously, happens after the event. So when they look back at the workload of that event, instead of coding the average workload, they code the highs and the lows, which may be only 2 or 3 of those events. So they integrate across those particular events, and they don't necessarily give you what is the average workload that you would have a look at.
Okay, so the idea is that you are interested in measuring average workload, but you're not actually measuring that.
If you are using subjective report, it's called memory contamination. You may, let's put it like this, you may wish to know only about those highs and lows. That may be, in this case, your goal of looking at cognitive thresholds. So there is no necessary dissonance, but in reality, you now, as a subject matter expert, have to say, what am I using this dipstick for? Am I using it in order to look at those violations, or am I looking at it to look at this person's chronic level of demand imposed? So those are 2 different, slightly different questions. But okay, primary task performance, the failure one we've already talked about. So they're useful, and they're usually the metric we compare against, but they're not the whole story. So we've got subjective workload. We're going to move into the questions, I think, quickly. All right, you can formally ask them. There are a variety of ones. When I was first working on this, I gathered together a SWOT and TLX. Those are easily available. Run them online, ask me for them if you want them. There are others, instantaneous workload scale. They're all scales that are generally psychometrically developed in order to ask questions for people about what are the basic components of workload that they see. We can do NASA TLX just quickly. It's there, okay. So NASA has in this case 6 different components: temporal demand, effort, stress, own performance, frustration, and physical demand. So you look at each of the individual's responses on those particular scales. You compare them to give an individual approach. That is, you ask people which of those you think is most important, down to which is least important. And usually in the information base, you can have physical workload on the bottom. It's not a problem. And so you get a score out of 100, an average score, and this takes about 2 or 3 minutes to do, and there are other approaches that now you can go even faster. So it's not a long time. So here's some of the sort of data that you might get. And this is work we were doing for a large wind power generating organization who I can't name because I signed something. But here's the sort of issues they were looking at. They wanted various zones and thresholds, so we developed some for them. We're looking in this case at where you might desire the workload to be. As our colleague just asked, you might look for peak levels of workload. You might say, what was the maximum workload experience in relation to a specific event? Or you might average, in this case, over a shift or a certain epoch. And so you would then get, in this case, thresholds. And we're talking about something like 60 to 70 as a threshold. This is what's called the wrong and strong technique. So it's not perfectly correct, but it's strong enough for you to reproduce for people and say, we don't want to go over this amount, and we don't want to peak out into, in this case, the chronic overload. So you can give them scales, in this case from a subjective perspective, in order to give you some values that connote workload thresholds. So there is a possibility of doing that. One thing you can see is that extreme air traffic control, and we're talking traffic control up into the 16 or 17 per unit, starts to get into that area. And we know that there's an interesting characteristic of what happens. So some of the research I did for FAA, we were working on something called en route air traffic control. At the time, there were 13 centers, en route control centers, that actively control the whole of the United States. The one we worked with was at Farmington in Minnesota, which in this case actually routes traffic, all traffic from the west into O'Hare, and if O'Hare screws up, everything else is going to go to hell. So I presume your networks have the same sort of nodes that are problematic. And so what we were looking at is how many aircraft can somebody control in each sector. And the very interesting thing is these guys will talk about having the picture. And no doubt your operators understand the same thing. They will have a general awareness of how the system is operating, and then you can keep adding things in. And in our case, we were doing experiments by adding greater number of aircraft sequentially. And so if you get a busy situation, I won't talk about what they talk about R side and D side and supervisors. We can talk about those if you ask specific questions or you want to come back to me later. But this is sort of looking at one controller. He's doing both his sides. And you can push him to 14 or 15 if he's an experienced controller and it's an average sector that he's done before, has experience with, and it's an average traffic pattern. You can push him to 15, and you can start to push to 16 aircraft, and this is pretty heroic. And then you get to 17, and you push to 18, and he loses the picture. Now, the interesting thing about the way he loses the picture is he doesn't lose one aircraft and keep the other 17 on board. He loses the lot. It collapses. This is quite typical of human beings. It's typical of the way you're going to die. I'm not going to look particularly at you, Jerry. That's not fair in life. I'm going to go to myself soon. It's called terminal drop. That's exactly what happens to human beings. We can talk about statistically why that's so, but in reality, most human beings don't have a graceful decline where all the Medicare expenses go, as USA Today would have it today. They go along quite well, and then boom, they have terminal drop. And some of these people, it's quite spectacular. So human beings fail, and they get to the edge of failure, then they drop off the table. So you are trying not to go into that region, and that particular level of workload is indicative of incipient failure. Yes, sir?
So, as we talked last night, there's little warning of that. Would you contact, is there some way, some warning sign we could look for? Because obviously a mitigation, maybe we can't plan around it, maybe we can mitigate it though.
Yeah, we'll push on to hours of boredom of modes of failure, and I'll finish on that. But the question is a perfectly prominent one, as they would say in The Simpsons. And what you look at is something called coefficient of variation. The system you possess right now is ringing, all right? Some are ringing more than others, but they're ringing. And so what we look at is the second moment of the distribution, the variability, in relation to the first moment of the distribution of behavior, that is the mean, and that division is called coefficient of variation, and you would recognize in engineering this sort of tremor, in this case an increasing variability, and it's certainly related to things like statistical process control of about 60, 70 years ago. So just go quickly, how much time have I got, James? I can speak forever, but you tell me.
Yeah, about 10.
10 more, okay. All right. So here's the latest and greatest. This is how most people will recommend you going, and we'll just run through some quickly. This is physiological measures, and what we're trying to do here is to take the output of the active central nervous system, both the central nervous system and the peripheral nervous system, and we're trying in this case to get measures of things that might now represent workload. One of the earliest ones, for example, that I've been focusing on here today, good signal, thank you. I know I've got 6 minutes left now. The point is that you can look at things like pupil diameter. So remember, if you want to know whether someone's interested, you can look at their pupil diameter. That's why it's always easier with people who've got light-colored eyes. What you find is that as their pupil actually expands, as it will do when they're interested, it's part of that 9,000 neurons they have no real control over. Then you'll know that they're interested in what you're saying. And then if you see the things go to little pinpoints of light, you'll know that you're pretty much losing. Okay, that's one measure there. There are hundreds of measures you can get out of the eye. The eye is a wonderful window on the soul, as they say, and there have been ultimately many, many used. There's one, for example, developed by some folks at Virginia Tech. It's called Workload, that you can use in this case for fatigue. So as I look at you here, I can look at, in this case, greater closure of blinks. If I see longer ones, those are ones lasting over a second. And as you see, as things go on, what you do is you can understand there's a direct relationship with the degree of experience fatigue. We can do a lot with pupil diameter. We can even draw bar graphs. Ooh, okay, visual scanning. We can look at how people move around the world with their visual scanning. James asked me to talk a little bit about what we call attentional narrowing, or sometimes called cognitive tunneling. So I'm going to do that. But if I were doing a visual scan, I would look at, in this case, I would look at visual variations, and I can show how those work. These are getting cheaper by the day, absolutely cheaper. They used to be extremely expensive. You used to have to take weeks, if not months, of post-processing. But nowadays you can buy systems, and pretty much soon you'll have one in your set of glasses here. You'll be able to scan, and post-processing software has improved so radically in this area that I'm even now thinking about doing it myself, because you don't have to spend months and months and hours doing post-processing. It starts to tell you what you're looking at. And here you've got a typical sort of thing. So what are people looking at? Good idea to be able to tell them. Inside the brain itself, here's all the, here's a variety, not all of them, but what we're looking at is trying to look at spatial and temporal resolution. And so what you find is that you have some, classically fMRI is, in this case, not too good on temporal resolution, but it's pretty great on spatial resolution. The trouble is you have to cart around a magnet, a behemoth. The United States Army paid me enormous amounts of money to find out whether you could put fMRI on a soldier's head as he was walking about the world. It turns out that would be a little difficult, but we could have a crane that moved the 2-ton equipment around on top of him. But there are ways of trying to solve those. You can look at some of the others. All I'm telling you is that what we're doing is we're trying to head down to that window on the brain that has both spatial and temporal resolution, down to the closest we can get in terms of milliseconds and millimeters. You've got transcranial Doppler sonography, which is very easy to do. You've got functional near-red functional near-red imaging, and again, you'll see lots and lots of that, and you're probably, as I say, already subject to that inadvertently, whether you actually know it or not, and believe it or not, the suite will come together, and we will have a variety of involuntary measures. The real question is, now you've looked inside the brain, what's it actually saying? That's something that's still to be determined, as it were. So here's a nice matrix you can look at if you're looking at various measures. You've got an enormous matrix as you look at them. Do you like reliability? Yes, well, that's good. Validity, sensitivity, diagnosticity. How much do you invade the person? How much do they know about it? How much is it going to cost you? So we have nice tables to tell you what it is you would put together. And of course, people are creating these sensor systems all the time. I'm not going to talk about that unless I'm specifically asked. So let's go to the problem that we're going to be looking at. So I talked about boredom being, in this case, the hidden problem. Boredom doesn't kill, it just sets the stage for death. And so hours of boredom are moments of terror, and as you take someone out of that inner loop, as you push them further from the inner loop, it really becomes months of monotony and then milliseconds of mayhem. And I hear that some of your things oscillate around 720 times per second, or even faster than that. And of course, when you get down to nanoseconds, human beings can only watch the disaster taking place. So we've got a few pieces of work there. These are some of the things we're working on for NASA. This is properties of the workload signal. These are the things in relation to our colleague's question over here. Do I want to integrate the areas of overload or underload? Do I want to look at the absolute level, number one? Do I want to look at certain step functions? Do I want to look at rates of change? Do I want to look at levels of stability inside or outside an acceptable envelope? How far does the past affect what I'm doing now? How far does thinking about the future affect what I'm doing now? And some of these have been investigated systematically and some haven't. Human beings, for example, have something called hysteretic tendencies. That is, the point is that the human beings don't recover linearly in time. They don't step backwards and forwards. They are sort of, the work we're doing, for example, with the Army, with trust. Once you fractionate trust, human beings tend to drop down very low, lower than they rationally should, and their recovery rate is much slower as well. Don't fracture the trust that your users will find a problem. So here's some of the things that was asked of me particularly. This is the notion of what happens as you start to get higher and higher levels of cognitive workload. So originally, let me give you a story, because I love stories. Let me imagine that you've rented a car somewhere, let's call it Atlanta, and you're not quite familiar with the car. It's got a few new curls that you don't have before, so you've got an interface you're having to wrestle a little bit with. And now you get out onto the roadway, but you don't have a GPS, and so the roadway's a little bit of a problem because it's a new one you've never done before. And then, lo and behold, you get into heavy traffic. It's not a traffic jam, but there's a lot of crazy people around you, and that's Florida for you. And then it starts to rain, and that's a problem, and yeah, it starts to pour down and bucket down, and then there's a work zone in front of you. So I want you to cognitively walk through that particular scenario, and what you find piece by piece is that you start off looking at all the blue skies around you, the happy Atlanta skyline, and you're doing quite a lot of scanning, and then as you're looking around the car, the new car, you're looking at the relevant things and trying to find out what they mean, and then as the traffic begins to go up, you're looking there, and now eventually you start to focus down on just one or two things, and you have what's called cognitive tunneling. In effect, what you're doing is you're just narrowing down to the single one source of information that's absolutely critical. And it's not necessarily a spatial thing. You don't just look straight ahead of you. You can actually, as I demonstrated it years and years ago, you can actually focus to one side or another. So don't think it's always in front of you. But in an aircraft, for example, that last station of the cross, as it were, is the altimeter. Am I above the ground or not above the ground? That's the only thing I really need to know. In driving, it's usually the straightforward field view. You do not look, you do not tune the radio, you don't even look around and talk to anybody when you get down to that level. The only point of this slide is it happens in time as well as in space. And so under extremes of stress, and I'm talking about life-threatening stress here, you get disorientations in time as well as in space. If you've ever experienced it, I don't need to say any more. If you haven't, there's not much I can tell you. You can have a look at this finger. I was riding a motorcycle in England. I was coming down a nice open roadway with trees either side, and somebody called a nice old gentleman out with a station wagon right across the front of me. I hit, fortunately, just behind his front wheel. I went over the top of the handlebars. I tore my leathers as we were going over the top. And even today, as I stand and speak to you, I can recall that particular event. Remember peak events that you can recall in memory? And I remember going over the front of the handlebars and looking at the roadway and saying, in this cadence, this is going to hurt. Now, it was probably objectively about a second, but what nature does for you there under extreme conditions is that it allows you to process a lot of information because your immediate survival depends upon it. And so what we can see here is that you get, in this case, distortions of space and time, and that's what you're going to do when you start to put people under extremes. And if you do the worst thing, which is you don't tell them exactly what the strategy is for success, they're going to narrow onto what they perceive as the greatest salience, whether it is or not. A couple more minutes, maybe one more. So we've got a lot of models that underlie these things, and some of I'm responsible for killing dead trees, and I apologize for that. So car crashes have an interesting thing. Roman was very nice to recognize me. Sometimes I do, sometimes I don't. The last time I spoke in Atlanta, that was sort of what I looked like then. And then I conducted an experiment, because I'm interested in experiments. I decided I was going to lose half my body weight. I'll answer questions if I have to. And that's me at the bottom of something called... well, that's me outside the house, but I was just outside something called Samari board. So, paradox is I now don't believe that any change is possible in the whole of the universe. So, that's a really weird way to finish, but you have, what, 5-7 minutes for questions. I'll be happy to ask any questions that people have of me, and I'll be happy to stay. And if you can't get your questions in today, please, A, come down and see us, especially when it gets cold up north. We call 78 a cold day. We occasionally use electricity, and so we'll do energy for you folks. So ask your questions, and I'll see what I can give for answers.
Leonard? Thanks, very interesting talk. You've had a number of observations, overload, underload, cognitive tunneling, things along those lines. How significant do those observations or those assessments change for somebody who's working days versus somebody who's working nights?
Okay, let's go fairly deeply into that. Actually, I haven't got the illustration here. I have Billy do the illustration. Okay, how deep you want to? Let's go deep. It's a good question. So let's go deep. The original work was not called circadian work. It's called diurnal work. The best book ever written is written by a guy called Nathaniel Kleitman. It's called Sleep and Wakefulness. It was published in 1939. It was republished in 1963. It's from the University of Chicago Press. And diurnal was the idea of day-night. Human beings are adapted to day-night. The general way you want to think about it is during the day, humans are predators. During night, humans are prey. So be careful, and this is why Parkinson's theories of why you sleep there. So human beings are not really built to do a lot during the night, especially because they're generally social animals. The word circadian, circa dies, was a relatively latecomer to the business because it was meaning about a day. So it was a development around the 1920s, and in fact, I had the honour of having the guy who coined the term working in my lab for a while. He was a senior advisor. The notion is that human beings have an intrinsic rhythm. Now, the interesting thing about the rhythm itself, which is best characterized as a body temperature rhythm, although you can see it in almost any non-stable element of the physiological system, is that it's not 24 hours. So human beings have what they call a free-running rhythm. So if I were to put you in a box, preferably an unlighted box, if I was French, you do it in a cave. If I'm German, you do it in bunkers. It's just the way things go. And the average free-running rhythm of human beings is about 24.5 hours. That is, if I was to look at the average variation around here, I would find some people who are oscillating less than that, but not much less than 24 hours. And I'd find some people who are 26 or 27 hours. You can try to go onto your free-running rhythm, but you will become slightly schizophrenic and certainly very asocial, and your family won't like you after about 3 or 4 days because you'll be pushing half an hour every day. Why the hell then don't we have a 24-hour rhythm? Why do we have a rhythm at all? Well, it's for adaptation. So you can imagine in the 1800s, as the Americans pioneers came across the prairies, if you didn't have an adaptive capacity, you would be stuck on Plymouth Rock time. You would not be able to change. And so the point is that the rhythm is not exactly 24 hours in order, in this case, to make it possible to adapt to new time zones and allow migration to occur as it did a long time ago. Your empirical question is night versus day. In general, the work you want as a general piece to read is something called The 24-Hour Society by a guy called Martin Moreed. Don't worry, this is being recorded, so you can have any of the information. Moreed is part of a group that was originally at Harvard, probably one of the best workers in this area in the world. It's a guy called Chuck Seisler at Brigham and Women's, and also I think he's at Harvard Medical School. And the basic bottom line is humans are not built to work at night. So, some of the empirical questions that are really interesting are, can you invert the circadian rhythm? Can you turn the rhythm over so that you actually are a night animal? No, you can't. There's been work tried at the Antarctic where you find that the rhythm is ablated, it's brought down, but it's still, the amplitude is decreased, but in this case it's never inverted. The classic work's done by a guy called Simon Folkard on night nurses in England, and he reported some very strange stuff about memory. The simple fact is human beings don't do so well at night, and you should not expect them to. And so, in fact, what we should do is we should begin to have dynamic displays, dynamic workstations, which individuals plug into in an individual or bespoke manner that understands what time of day and night we are working. So, one of the most interesting developments we're seeing in the safety area recently, and is epitomized by a book called Safety 1 and Safety 2 by a guy called Harry Kolnagel, who was employed for years and years on questions of power generation by, in this case, the government of Denmark, is where the human beings are actually needed in the system in order to generate variability. That's a very, very different mindset and philosophy from the usual idea of damping out as much variability as is humanly possible. So you should cater to that particular variation and be very aware of it. Have I answered your question, or do you need some more?
So what I took from that and what I took from your earlier conversations is that your ability to absorb additional pieces of information are probably lessened in the evening lessened at night, but your propensity towards boredom is probably lessened overnight as well.
I don't know about the latter. Certainly the former is the case. And in fact, I've already shown that experimentally that that you do get a circadian rhythm in the stable level of workload that people do for a constant task. So you do the constant task at different times of the day and night, and they experience different levels of workload, both primary task reflective, but also secondary task techniques that I talked about, and some physiological reflections. Whether you do the second, I don't know, and I don't know who would know. The guy I would probably ask about that is a guy called Jerry Matthews, who's extremely good on stress and workload and boredom. Thank you, Leonard.